Welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mask coder this side. In this video, we are going to discuss lecture number 10 of the linked list series. We have made this so far, and congratulations if you are following it. Now, the question says find the middle element of the linked list. Find the middle element of the linked list. And as you can see, the question is itself clear. You have been provided with the linked list. As you can see, suppose 1, 2, 3, 4, 5 is the linked list. We have to return the middle element. Now, in the case of even, we all know that there are two mids. 3 is one of the mid, 4 is one of the mid. So in that it is returned, if there are two middle nodes, we will have to return the second middle node. So I will choose 4, right? As you can see, red one is the highlighted, which is my answer. Now, how will I solve it? How will I solve it? So I'm sure by now many of you have understood that I will find the length. I will divide by 2. That is some position of my linked list, the node I want to do, and then I will traverse up to that node, right? I will traverse up to that node. Okay, so let us take an example. So if we have an odd length linked list, let us do it first for odd. So whenever you encounter such cases which are sensitive to odd and even, I recommend you to make two test cases to test your dry code and then do it for that. That is, first draw a linked list for odd length, then for even length, and then try it out, right? So first for odd. So 1, 2, 3, 4, 5. How will I find length? So I will not explain again. The length will be found by the traversal. I have already discussed it in the playlist. You can please watch the video. The link is present in the description. So please make sure to check it out if you are not familiar with the length, right? So traversal will give me length. Traversal will give me length. So in this case, my length is 5. In this case, my length is 5. What is my target? I want to reach here. I want to reach here. I want to reach here. So I can say if I do 5 by 2, that will give me integer division 2. But I wanted to reach third position. I wanted to reach third position. So I can say if 2 plus 1 equals to 3. So n by 2 plus 1 in the case of odd is giving me the position. Is giving the position. But I don't want the position only. I want the element as well. I want the node as well. So what will I do? Simple traversal. My head is here. I will keep my temp here. I will say temp equals to temp next. Temp comes here. Temp equals to temp next. Temp comes here. And I can simply turn it. So how many jumps did I take? This was my first jump. This was my second jump. I had my position as 3. I had my n by 2 as 2. I had to make n by 2 plus 1. That is position minus 1. That is n by 2 jumps to reach the answer. This is in the case of odd. Now let us explore for even as well. As I said, when the answer is sensitive to odd and even, just draw two test cases, one for odd, one for even, and try turn your approach. Moving towards the even one. Moving towards the even. This is for even, right? Suppose your linked list is 1 connected to 2, connected with 3, then 4, then 5, then 6. The answer is 4. As we saw above, the answer is 4. The length of the linked list is 6. The length of the linked list is 6. So 6 by 2 is equals to 3. Right? What is the position? My position is 4. That is 3 plus 1. That is n by 2 plus 1 is my position again. And again, 1 jump, 2 jump, 3 jump. That is position minus 1. That is n by 2 jumps. N by 2 jumps. The no problem. No problem in this, right? No problem in this. N by 2 jumps and n is the length, right? Length by 2 jumps, right? The problem I have is with the double traversal. The problem I have is with the double traversal. What do I mean by that? The term double traversal. I mean that you are traversing the linked list 2 times, right? If I'm not wrong. What is the 2 times? So first time is for length. As those who know how to find the length, you might be knowing that how to do the traversal, right? And then find the length, right? So first traversal, find the length. So O of n is the time complexity here. Second one is to traverse again n by 2 times, right? Getting mid. So it is O of n by 2, but it will get converted to O of n. So you are actually using O of 2n, right? It is a linear time complexity, but O of 2n is such a not great deal, right? You must have to see that can I optimize it? Can I bring down to O of n? Can I bring it down to O of n? And the answer is yes. How? So if you have watched the previous lecture where I was deciding whether there is a loop or not, the answer lies here. The answer lies there. Yes, you are correct. If you have seen the previous video, slow and fast. Slow and fast. The approach is simple. If there is a person A and there is a person B, if the person B is running 2 units per second, person A is running 1 unit per second, at the finish line when B will be finishing, my A will be at middle. my A will be at middle. This is the approach, right? This is the approach. If B is running at double speed than A, then A will be at middle when B has finished the race line, right? This is the approach. So let us try it out for odd and even again, right? So for odd, 1, 2, 3, 4, 5. What will I do? I will again keep a slow here. I will again keep a fast here. Start reversal. Slow moves one node. Fast moves two nodes. So fast comes here. Now slow moves one node. Fast moves two node. Right? And as you can remember, to avoid the segmentation fault, my condition was while fast is not null and my fast next is not null. My fast next is not null. And as you can see, for the fifth node, fast next is null. So I will break this loop and you can see my slow is aligning with my tree. So for odd, it is running fine, right? Let us try it for the even as well. Let us try it out for the even as well. So for even, 1, 2, 3, 4, 5, 6, right? So slow here, fast here. Slow comes 1, fast comes 2. Slow comes 1, fast comes 2. Slow comes 1, fast becomes null. And as soon as null, again this while fast becomes null, break out of the loop and your slow is aligning with your pointer. You wanted 4, slow is at 4. You wanted 3, slow is at 3. The approach is simple. It is working for even as well as odd. So what is happening is my answer is looking something like slow equals to head, right? Fast is equals to head. Now, while my fast is not equals to null and my fast next is not equals to null, right? What will happen? While slow will move, sorry, it is S equals to S next and fast equals to faster next, right? After the loop finishes, my slow is at my answer, so return slow, return slow. This is your approach. This is your approach. And I hope there is no error. It is actually running in O of n by 2 times. And that was running in O of 2n times, right? O of n by 2. Why? Because my fast is in 2 speed and my slow is actually traversing only one time, right? So n by 2. Okay, so let us start with the code now. I hope the question was clear to you. Let us start with the code and then we will see if any other doubts are left. Alright guys, so here we are. Before starting with the code, I would like to request you again to please subscribe to my channel because it means a lot to me, right? It feels good when the subscriber range goes up, right? You might be understanding what I'm trying to say. Okay, so first node is slow, initializes head. Similarly, fast is also head. Now what do I have to do? My loop will run while my fast is not null and my fast next is not null. What is happening? Slow becomes slow next and fast becomes fast next, fast next. At the end of the loop, return your slow. Hope it will run fine. Let us try to compile and run it. Hope I have not committed any typing mistake, right? There is a typing mistake. What is it? It is not FADT, it is FAST. Again, run it again. Running fine. Let us try it for submit as well. It is running fine. So thank you for watching. I hope you like the solution. I hope you were able to understand the lecture. And as I said, linked list is all about visualization. So we'll meet again in the new lecture. Till then, keep coding, stay safe and stay tuned. Okay, have a nice day. Bye.